Good morning, everybody. So we got our test on Friday. Please try to do at least 10 of those problems that are on the review. That's that's the bare minimum. You should really be, as we're doing this lecture right here, pause the video and try to do what's being asked before the answer is revealed to you, and then look back at the old assignments and try to do very, very well on this test the first time. So we have this page about factoring. We're going to factor these four. And the first rule of factoring is we really have to pull out a greatest common factor. These three, they all have an x in common for sure. They have one x in common, but they also have a 3 in common. So 3x is the GCF, and that's going to continue on all the way for the rest of the problem. That GCF is going to be part of my final answer. And then once I take out 3x, what's left over? X squared plus 3x plus 2 if I divide each by 3x. Now I've got this trinomial with a 1 right here. So now I have to find two numbers that multiply to 2 and add to 3, and they are 2 and 1. So this trinomial factors into 3x times x plus 1 times x plus 2. And based on what we were studying just recently, we know how factors are related to zeros. So if I were to graph this, it would have three x-intercepts. One would be at -2, another x-intercept would be at -1, and then this one would be at 0. So it would hit the x-axis 3 times. For here, again, GCF, these both have a 4 in common. So you're taking out 4, and that's going to be part of your final answer. When you divide both of these by 4, you're left with x squared minus 25, and that is a difference of squares. This is a square minus a square, so that factors into x minus 5 times x plus 5. You take the square roots of both. One of them is minus, one of them is plus. Here, there's no GCF besides 1. So when the GCF is 1, you don't take it out because dividing by 1 doesn't change anything. But again, this is another trinomial where the a value is positive 1, which makes our job a lot easier. All we have to do is find two numbers that multiply to -22 and add to -9. Those two numbers are -11 and 2. So this factors into x minus 11, x plus 2. And again, worth noting that if you were to graph x squared minus 9x minus 22, the minus 22 tells you the y-intercept. So there's a y-intercept way down here at 0, -22. There are two zeros. One of them is at -2. -2 will make this 0. And the other one is at positive 11, because 11 will make this 0. And then we could just connect those dots and then graph your parabola. This one, the GCF is 1, so taking that out is not going to help me. The a term is not 1, it's 8. So this one is more involved. This one might be best to use master product. So you multiply the outer numbers, 8 times 9, and you have to find two numbers that multiply to 72, but at the same time add to 18. So let's see here. You always have a calculator available for you if you need one. And two numbers that multiply to 72. Well, so 72 divided by 2 is 36. Remember, I need two numbers that multiply to 72 but add to 18. So 2 and 36 aren't going to do it. Let's try 72 divided by 4. 4 and 18, no. 72 divided by, I know 5 doesn't work because it doesn't end in a 5 or a 0. So maybe 72 divided by 6. 6 and 12, oh, okay, 6 and 12. 6 times 12 is 72, and 6 plus 12 is 18. So those are the two numbers. That's the hardest part, is finding those two numbers. What do you do with those two numbers? You split up this middle term. So instead of 18x, you're going to write 6x plus 12x. It doesn't matter what order. You could write 12x plus 6x, and it'd still be okay. Once you have four terms, you factor 3 times. The GCF of these two, they both have a 2x in common. And you factor that out, you're left with 4x plus 3. These two both have a what in common? A 3. You take that out, you're left with 4x plus 3. And then both of these two big groups have a 4x plus 3 in common. You take that out, and you've got it. This is the final answer. And just do a quick mental check. You have to, when you multiply these two, you have to get this. Well, 4x times 2x is 8x squared. So that's good. 3 times 3 is 9, which is what I needed here. Now, do I get 18x in the middle? Yes, you do. If you multiply the outer two, 4x times 3, that's 12x. And 3 times 2x is 6x. And 12x plus 6x is 18x. Last one. Find the vertex form of this. You have to remember that vertex form looks like this. And the a in vertex form is the same a in standard form. And just yesterday, it's the same a in factored form. So that's a big help. So I know my answer for vertex form, there's going to be a 3 right here because the a value is 3 right here. How do you find the vertex? Remember, the vertex is, for a quadratic, the vertex is negative b over 2a. That's the x part. And then you plug that in to f to find the y part. So first things first, you have to find the x part first. So negative b over 2a, that's negative 12 divided by 2 times 3. And that's negative 12 divided by 6, and that's negative 2. So the x part of the vertex is negative 2. What's the y part? You have to take negative 2 and plug it into f to find y. So f of negative 2. So now it's going to be 3 times negative 2 squared plus 12 times negative 2 minus 13. And you show all your work, and you get negative 25. So the vertex is negative 2, negative 25. That is the vertex of this quadratic. And then you plug it into here. We already know a was 3, right? The h value is the x part of the vertex. So this is x minus negative 2, which is x plus 2 squared, plus the k value. The k is negative 25. So if you add negative 25, that's just minus the negative 25. So there you go. This is the vertex form. Good luck, everybody.